Audio Jungle. Audio Jungle.
All right. So, like in last session, you have seen that velocity potential function, stream function, and characteristics of the streamlines and equipotential line characteristics. Also, you have seen, right? Now we'll talk about the rotation. Fine. Okay. So, what do you mean by rotation? So, rotation is basically you can say it is it is the angular velocity of particles, okay, about about its own axis or about its own center of mass, right? What is the mean of it? Suppose this is the fluid flow. This is the fluid flow, and in this fluid flow, suppose I am taking one rectangular fluid element. This is the one rectangular fluid element I have taken. Okay. Now I have taken this rectangular fluid element. Okay. Just say this rectangular fluid element is A, B, C, A, B, C, B. Yes or no? Where is the center of mass of this particle? One particle I have taken. I can say this is the center of mass. Perpendicular to this, there will be one axis, that will be the axis of rotation. Yes or no? Perpendicular to this, you can say this is the axis of rotation for the particle. Yes or no? This is the one particle, and we have find the center of mass of this particle, and perpendicular to this center of mass one axis will be there, and around that axis that particles will rotate. That will be the axis of rotation. Hope you understood. Yes or no? How that rotation will be? See, now I'm considering this is what, just say this is what the fluid flow. All right. So one particle I'm considering here. That particle is what here? Fine. This is one thing. Okay. Another, I will show another diagram. Try to connect it. You may get. Okay. We'll give the naming. Okay. And two different cases I have taken. For the particles, I have taken two different cases. Okay, fine. This is the one case. This is the another case. Okay, both are having separate case. In this case, that particle, okay, there is the axis or the particles, but particle is what? Not rotating about their own axis, not rotating about their own axis. Here that particle is what? Check it. Here particle is what? We have rotation. That particle is what? Rotating about their own axis. Okay, two different cases I have taken. One, this is the case one, and this is the case two. So case one and case two, you can observe that particle is what? During the flow, that particle is what? Not rotating in case one, and second case I have taken where the particle is what? Rotating about their own axis. If it is rotating about their own axis, then it is called rotational flow. What it is called? Rotational flow. Means particle is flowing, at the same time it is rotating also. It is rotating its around its own axis, then it will be called as a rotational flow. What about this? This is called irrotational flow. Okay, so and in case one also, that fluid is not rotating about its own axis, but it is flowing. I mean, fluid is what? Flowing, but particle are not rotating, or one particle, if you say that that particle is not rotating about their own axis, but it is flowing, it is called irrotational. But during the flow, if particle is also rotating about their own axis, it will be called as a rotational flow. Hope you understood this. It will be called as a rotational flow. So two types of flow we got now: rotational and irrotational. All right, that is the one thing. So now this rotational velocity will be also called as a this rotational will also be called angular velocity. Okay, and it is denoted by omega. All right. So now we'll talk axis system and then we'll talk about plane. Okay, two things we have. What is that? Axis. Based on axis, because if you write the angular velocity for 3D flow, okay, so it will come like omega is equal to, because it is the vector quantity velocity, so omega xi omega yi, omega z k. So here we have I, here we have j, here we have k. So if it will rotate about x axis, it will be called as omega x. If it is rotating about y axis, it will be omega y. If it is rotating about z axis, it will be omega z. That is the based on axis. Okay. Rotational velocity here you have written based on axis. Fine. Now how to write this rotational velocity or angular velocity based on plane? So here you can say rotational velocity, or it is also called angular velocity based on plane. How to draw it? Also check. X, y and z. Now if you talk about the plane, so I will show the plane. Okay? This is the one plane called XY plane. All right. This is called XZ plane, and okay, this is called YZ plane. Yes or no? Now, so if you say there is the angular velocity, if it is rotating about one axis, all right, and now you are talking about based on plane. If I say XY plane, okay, if I say XY plane, so where is the XY plane? Check. This is what XY plane. So perpendicular to this XY plane, okay, will have a perpendicular to this XY plane. What is that? That is Z axis. Yes or no? Perpendicular to XY plane will be what? Z axis. So here you can say about Z axis. You can say XY plane. So definitely it will rotate about one axis. So on XY plane, what will be the perpendicular axis? It will be Z axis. So now angular velocity will be omega z, and it is the one derivation, but directly here I am showing you how to remember x, y, z. After z again x will come, okay, because you are talking x, y plane, so x will come and y will come. What is the y? In y axis, what is the velocity component? Okay, in y axis, what is the velocity component? In x axis, velocity component is u. Here it is y. In y direction it is v, in z direction it is w. Okay, so in y direction what is the velocity component? It is v, so you have to write v here. In x axis what is the velocity component? It is u. So it is u. Similarly, I want to write what xz plane. Where is the xz plane? Check. This is what xz plane. So perpendicular to this axis. What is the perpendicular to the xz axis? It is y. So you can write about yx. So here you can write 1 by 2. It is xz. So dou z minus dou x u and means just opposite. If you are writing dou x, why you are writing xz or zx plane? Okay. If there is a confusion, so I must write here zx plane. No? So that time will not have any kind of confusion. Just say zx plane. So zx plane dou z and x, so dou x, just opposite velocity component you have to write with minus, and this is the one derivation, but I am showing you how to write the formula directly because you are not going to derive in exam. Okay. Now what is the next axis, which is called yz axis? Okay, yz axis. So now you can write here yz plane, not axis, yz plane. Where is the yz plane? This is. What is the perpendicular axis to this yz? Perpendicular to this. Perpendicular to this yz. What will come? Check, or if it is not clear, you need to write this one. Check properly yz. So yz perpendicular axis will be what? It will be x-axis. Check in this way. Huh? So it is nothing but about x. What formula you may get? Wx 1 by 2 in bracket yz. So dou y minus dou z dou w dou v. Yes or no? So this is the formula wx, wy, wz. Okay. So again I will write it. Hope you understood how to remember it. Now another way I will tell you how to remember. This is the one circle I have formed. X, y and z. If you are writing wx, so 1 by 2, now check. After x what will come? After x y will come. So here you can write w, do wy, and after y what you may get? Z. So do z. Numerator for the dou y will be just opposite of the velocity component, like just opposite in the sense in z direction, but will be the velocity component w. So here you have to write just opposite w. In y direction what will be the velocity component? It is v. So you have to write v. This is the formula. Similarly wy. How to write? Check. After y what you may get? After y you may get z. So you have to write dou z. After z what you may get? X. So dou x. Here in numerator x direction what is the velocity component? It is u. So u. In z direction what is the velocity component? W. So w. Okay. After z what you will get? X. After x what you will get? Y. What is the velocity component here? You will get in y direction it is v, so it's v. In x direction what is the velocity component? It is u, so u. This is the formula. Simple. Yes or no? Simple formula only. I hope you understood this. Now our main motive to this, to write this equation, first it is very important. Okay, it is asked in exam also if you know the formulation of it. So don't go for derivation and all. Whatever the tricks I have given to you, like how to remember, you have to remember in that way only. Now basically we need to satisfy the potential function as well as stream function, okay, with this angular velocity, so that we can check the rotationality and irrotationality of the fluid flow. All right, so now first we'll try for the stream function. Okay, first we'll try it to write for the stream function. So now, as we know stream function given as follows. What it is? It is dou psi by dou x v and dou psi by dou y, it is minus u. This we know. Now we know the, now based on this you can say this is what, xy plane. Now so we can write angular velocity on, if I am saying xy plane means about z axis or not, check. Somewhere I have written about xy plane, see, about xy plane or about z axis. On xy plane or about z axis, meaning will be same. So here I have written on xy plane or about z axis. Huh? So that meaning will be same. So there should not be any confusion. Both are same. So what is that? Wz 1 by 2 yes or no? Now we'll satisfy this 1 by 2 dou by dou x. What is v? Check. Dou psi by dou x minus dou by dou y. What is u? U is nothing but minus dou psi by, okay, this is the one thing. Fine, we can break it. What will get? 1 by 2 dou square psi by dou x square minus minus plus dou square psi by dou y square. Agree? So what we got? What we got here? 1 by 2 dou square psi by dou x square dou square psi by dou y square. If I can write here, if flow is irrotational, flow is irrotational, what is the mean of it? Means flow is not rotating about their own axis. So what is the mean of it? If it is not rotating, then angular velocity will be 0. What angular velocity it is? Omega z. Yes or no? So I must say 1 by 2 and this value will be 0, or 1 by 2 will also be go to 0, so it will be or this is what is this? This is what? This is the Laplace equation, we can say. Yes or no? This is the Laplace equation or not? Huh? So we can say this is Laplace equation. What is the conclusion? What is the conclusion? We need to check. The conclusion is if a stream function if a stream function psi satisfies the Laplace equation, it is possible case of irrotational flow. Okay, if you got it, no? When you got grad square psi is equal to 0, when you consider flow is irrotational, then only you will get this, right? Check, you have said here when flow is what? Irrotational. Yes or no? If flow is irrotational, then only then you got this Laplace equation. So if it is stream function is what? If it is satisfying the Laplace equation, okay, then it means it is the possible case of irrotational flow. This is the conclusion, very important. Okay, this is the conclusion in terms of the stream function I have explained. Same thing we can do for the in terms of potential function also. Yes or no? In terms of potential function also we can write what we can write for in terms of potential function. Check. Just like stream function you have written, similarly we have to write, we know velocity potential function. What is that? U is equal to dou phi by dou x, v is equal to dou phi by dou y. Okay, and this is what on xy plane, dou phi x and y term we are getting, hence it is xy plane. Now we know angular velocity on xy plane, it is also about z axis. Yes or no? What is that? Omega z 1 by 2 . Yes, we need to satisfy this. What will get? One by two dou by dou x. What is v? Dou phi by dou y. What is u? Dou phi by dou x. Okay. Then next will be what? Take, multiply and all. So it will be 1 by 2 dou square phi by dou x dou y minus dou square phi by dou x. If, what you have to mention? If flow is irrotational, if flow is irrotational, then what will be omega z or wz? It will be 0. Yes or no? So what you will get? Omega z, which is nothing but 0. Or what will get? Yes or no? Very simple mathematics. Yes. What is the conclusion point? And when you are getting this, when you have assumed the flow is irrotational, when you have assumed the flow is irrotational, then you got this result. What is the conclusion? Conclusion is very clear. Velocity potential velocity potential function satisfies the condition for irrotational flow, which means existence of velocity potential function means that a possible flow, that possible flow and irrotational. For that reason, one flow called potential flow. From this conclusion, very important conclusion is what? Potential. So what is the potential flow? The potential flow is nothing but combination of steady, steady, incompressible plus irrotational flow will be called potential flow. Okay. If I say potential flow, what is the mean of it? Mean is very clear. I told you, steady, incompressible, irrotational, and this will be called ideal. Okay. So always remember, if you say ideal flow, so ideal flow is nothing but potential flow If you say potential flow, it means a steady, incompressible and irrotational flow called potential flow. Hope you understood. So till what today I have explained, it is very important. Okay, and next class we'll talk about verticity. We'll talk about circulation. I hope whatever today I have taught is very clear to all of you. Still, you may have any kind of doubt. You write comment on comment box. Definitely, I will reply. Thank you all.